Terraforming Titan, why Saturn's moon might be better than Mars, a cosmic canvas. Picture this. You're standing on a frozen shore, looking up at a sky where Saturn hangs like a giant painting with its beautiful rings. Strange lakes filled with liquid methane shine under an orange glow, and the air is thick with nitrogen gas. This isn't Earth, but it's not completely alien either. Welcome to Titan, Saturn's biggest moon. A place that feels like something out of a sci-fi movie, but it's absolutely real. For years we've dreamed about turning Mars into a second Earth. Movies, books and scientists have all talked about making the red planet our new home. But what if we've been looking at the wrong place? What if Titan, with its weird beauty and hidden possibilities, is actually a better choice for humanity's future in space? This journey will explore why making Titan livable might be better than trying to fix Mars, Venus or even Europa. We'll look at the science, talk about the problems we'd face, think about whether it's right or wrong to change entire worlds, and imagine what life on a new Titan could be like. Get ready. We're going on a trip to a moon that might completely change how we think about living in space. The idea of changing other worlds to support human life isn't just modern thinking. Ancient people changed their environments too. The Egyptians built canals to control the Nile River. The Chinese built terraces on mountains to grow food. Now we're thinking about doing the same thing, but instead of changing rivers and mountains, we want to change entire planets and moons. It's the same human drive to make our surroundings work better for us, just on a much bigger scale. Historical context: the dream of terraforming. The idea of terraforming, changing an alien world so humans can live there, started in science fiction stories but became serious science in the 1900s. In 1961, a famous scientist named Carl Sagan suggested we could change Venus by putting special algae in its atmosphere to eat up the poisonous carbon dioxide gas. By the 1990s, Mars became everyone's favourite choice for terraforming because it's close to Earth and has some Earth-like features. NASA's robot missions to Mars showed us a red planet with ice at its north and south poles, old dried-up riverbeds, and a thin atmosphere. This got people excited about the possibility of bringing Mars back to life. Scientists and dreamers started making plans for how we could make Mars green and blue like Earth. Titan was discovered much later. In the 1980s, space probes gave us blurry pictures of a moon covered in thick, hazy atmosphere. But we didn't really understand what Titan was like until the Cassini spacecraft arrived at Saturn in 2004. In 2005, a small lander called Huygens actually landed on Titan's surface and sent back amazing pictures and data. What Huygens found changed everything. Titan had lakes, rivers, and even rain. But instead of water, everything was made of methane, a gas we use for cooking and heating on Earth. Suddenly, Titan wasn't just another dead rock in space. It was a world with weather, with liquid flowing on its surface, and with chemistry that could be useful for humans. The history of terraforming ideas shows us something important about humans. We've always wanted to make our environment better. Ancient people built cities in deserts by bringing water from far away. They turned forests into farmland and swamps into solid ground for building. Terraforming a planet or moon is just the next step. It's like building a pyramid, but instead of moving stone blocks, we're moving gases and changing entire atmospheres. Core scientific facts: the terraforming showdown. To make any world livable for humans, we need three main things: liquid water, air we can breathe, and stable conditions for growing food. Let's look at how 4 different worlds stack up: Mars, Venus, Europa, and Titan. Mars, the red planet's promise and problems. Mars has been the star of terraforming dreams for good reasons. It's relatively close to Earth, about 78 million kilometers away on average, and a day on Mars is almost the same length as a day on Earth at about 24.6 hours. Mars has ice at its poles made of both water and carbon dioxide, and its soil contains iron that could help plants grow. But Mars has some serious problems. The air is 95% carbon dioxide, which humans can't breathe, and it's incredibly thin, only 0.6% as thick as Earth's atmosphere. This means there's almost no protection from dangerous space radiation. The average temperature is minus 60 degrees Celsius, cold enough to freeze your breath instantly. Dust storms on Mars can cover the entire planet for months at a time. To make Mars livable, we'd need to make its atmosphere much thicker. Some scientists have suggested exploding nuclear bombs at the poles to release gases or crashing comets into the planet to add more atmosphere. We'd need to warm up the planet, maybe by adding special greenhouse gases to trap heat. Most importantly, we'd need to create oxygen, lots and lots of it. Even if we could do all this, it would take hundreds or thousands of years. And Mars has another problem. Its gravity is only 38% as strong as Earth's. Living in low gravity for long periods causes muscles to get weak and bones to become brittle, which could be dangerous for people born on Mars. Venus, the hellish twin. Venus is almost exactly the same size as Earth, and it's actually closer to us than Mars is, but Venus is basically hell. The surface temperature is about 460 degrees Celsius, hot enough to melt lead. This heat comes from a runaway greenhouse effect caused by an atmosphere that's 96% carbon dioxide. The air pressure on Venus is 92 times stronger than Earth's, which would crush a human instantly. It's like being 900 meters underwater. A day on Venus lasts 243 Earth days, and it rains sulfuric acid from the clouds. Yes, acid rain that would burn through your skin in seconds. To make Venus livable, we'd need to cool it down dramatically. This might work by putting giant sunshades in space to block sunlight from reaching the planet. We'd need to remove about 90% of its atmosphere, possibly by turning the carbon dioxide into solid carbon, or somehow blasting it into space. Venus has almost no water, so we'd need to bring water from comets or other places. The whole process would take thousands of years, and require more energy than humans have ever used in our entire history. Venus might look like Earth from space, but it's probably the hardest world to terraform in our solar system. Europa, the icy ocean moon. Europa is one of Jupiter's moons, and it's a fascinating place. Under its frozen surface, Europa has a global ocean that might contain more water than all of Earth's oceans combined. The surface is covered in ice and is extremely cold, around minus 160 degrees Celsius. But heat from Jupiter's gravity keeps the underground ocean liquid. Europa's thin atmosphere is made of oxygen created when radiation from Jupiter splits apart ice molecules on the surface. But this atmosphere is incredibly thin, about 10 billion times thinner than Earth's. To terraform Europa, we'd need to melt the surface ice to reach the ocean underneath. This might work using giant mirrors in space to focus sunlight, or by building nuclear reactors to produce heat. We'd need to make the atmosphere much thicker, and find ways to protect people from Jupiter's deadly radiation. Europa's gravity is only 13% as strong as Earth's, which would cause the same health problems as Mars. The biggest problem with Europa is that we don't know what's in its ocean. It might be incredibly salty, or it might be acidic. We also don't know if there's already life in Europa's ocean, which would make terraforming ethically complicated. Titan, the methane wonderland. Now let's talk about Titan. It's about 1.4 million kilometers from Saturn, which makes it farther from Earth than Mars but closer than Europa. Titan is actually bigger than the planet Mercury and has gravity that's 14% as strong as Earth's, similar to Europa but easier to deal with than Mars. Here's where Titan gets interesting. Its atmosphere is 1.5 times thicker than Earth's atmosphere. It's mostly nitrogen at 98% with small amounts of methane. This is actually great news because Earth's atmosphere is 78% nitrogen. Titan is very cold, with an average temperature of minus 179 degrees Celsius, but it's an active world with volcanoes that erupt ice instead of lava, lakes of liquid methane, and weather systems with methane rain. Titan's biggest advantages are its thick atmosphere and abundant resources. Having a nitrogen-rich atmosphere means we're already halfway to having breathable air. The methane and ethane lakes could be turned into fuel for rockets, or converted into plastics and other materials. There's plenty of water ice under the surface that could provide drinking water. The main challenge with Titan is temperature. It's so far from the sun that warming it up would require massive amounts of energy, possibly from fusion reactors or giant mirrors in space. We'd need to add oxygen to the atmosphere so people could breathe. Titan's distance from Earth, about 1.2 billion kilometers, would make it very hard to send supplies or people back and forth. Why Titan might be the best choice. When you compare all four worlds, Titan has some unique advantages. First, its atmosphere is already thick and made mostly of nitrogen, which is exactly what we need. Mars and Europa have almost no atmosphere, while Venus has too much of the wrong kind. Titan gives us a foundation to work with instead of having to build everything from scratch. Second, Titan has resources we can use. The methane lakes could power our machines, and there's plenty of water ice for drinking and growing food. Mars has some water, but not nearly as much. Venus has almost nothing useful, and Europa's resources are locked under thick ice. Third, Titan offers better protection from space radiation. Its thick atmosphere acts like a shield, and it's far enough from Jupiter's dangerous radiation belts. Mars has little protection, Europa sits in Jupiter's radiation zone, and Venus, well, Venus has other problems. The main downsides to Titan are distance and cold. It takes about 9.5 years to travel from Earth to Saturn, which would make supply trips very expensive and rare. The extreme cold would require advanced technology to keep people warm, but unlike Venus's deadly heat or Europa's radiation, Titan's problems seem solvable with better technology. New challenges and considerations. Beyond the basic science, terraforming Titan would face several unique challenges that don't apply to other worlds. The psychological impact of living so far from Earth could be severe. People on Titan would see Earth as just another star in the sky, if they could see it at all. The communication delay between Earth and Titan is about 80 minutes, meaning real-time conversation would be impossible. Titan's seasons last about 7.5 Earth years each, because Saturn takes 29 years to orbit the Sun. This means people would experience incredibly long periods of winter and summer, which could affect both crops and human psychology. The low gravity, while easier to deal with than Mars, would still cause health problems over time. Children born on Titan might never be able to visit Earth because their bodies couldn't handle our stronger gravity. The economic challenges are staggering. Every tool, every computer chip, every piece of complex equipment would need to be either brought from Earth at enormous cost or manufactured on Titan with resources that might not exist. Creating a self-sufficient industrial base on Titan would be like rebuilding human civilization from scratch. There's also the question of governance. Who would make decisions about how to terraform Titan? What laws would apply? If different countries or companies funded different parts of the project, would Titan end up divided like Antarctica, or would it become a unified human settlement? Philosophical and ethical dilemmas. Terraforming raises big questions about right and wrong. Are humans playing God by reshaping entire worlds? The ancient Greeks told stories about people who tried to rival the gods and were punished for their pride. Terraforming Titan could be humanity's greatest achievement, or it could be our downfall. If we change Titan, what happens to its unique environment? Some scientists think Titan's underground ocean might have microbes or other simple life forms. If we terraform Titan, are we destroying potential alien life before we even discover it? This would be like burning down a library before reading any of the books. There's also the question of why we want to terraform at all. Is it about ensuring human survival? If Earth becomes unlivable, is it about exploration and adventure, or is it about proving that we can do it? The ancient Egyptians built pyramids to cheat death and live forever. Maybe terraforming is our modern version of building pyramids, a way to make sure humans survive as a species. But what kind of life would people live on Titan? The low gravity might make people weaker over generations. The alien landscape might make people feel isolated and depressed. Would children born on Titan still feel human, or would they become something new? There's also the question of fairness. Terraforming would cost trillions of dollars and take centuries to complete. Only the richest countries and companies could afford it. Would Titan become a playground for the wealthy while poor people are left behind on Earth? Or could it become a fresh start where everyone has an equal chance? Possible future scenarios. Let's imagine 3 different ways Titan's future might unfold, each based on different choices we could make. Scenario 1. The methane metropolis. By the year 2300, humans have solved the energy problem with fusion power, the same process that powers the sun. Giant mirrors in space focus sunlight onto Titan, warming the surface to about -50 degrees Celsius. This is still very cold, but warm enough for liquid water to exist in protected areas. The first cities on Titan are built inside huge domes that keep the heat in and the cold out. These domes are amazing to see, glowing like gems under Saturn's rings. Inside, millions of people live in tall buildings made of ice and strong plastics created from Titan's methane. The methane lakes are harvested like oil wells, providing fuel for rockets and raw materials for manufacturing. Water ice from under the surface is melted to provide drinking water and to water crops grown in special farms that don't need soil. Special plants and bacteria, created by genetic engineering, slowly add oxygen to the atmosphere. Over time, parts of Titan become breathable without spacesuits. The challenges in this scenario include health problems from low gravity. People might need to wear special exoskeletons to keep their bones strong, or scientists might use gene therapy to help human bodies adapt. Because Titan is so far from Earth, the colony must make everything it needs locally. Over time, the people of Titan develop their own culture, mixing traditions from Earth with new ideas inspired by their alien home. Imagine walking through one of these dome cities. The air inside is warm and breathable, but through the transparent walls you can see Saturn hanging in the orange sky like a giant balloon. Children who have never seen Earth play in parks where the plants are a mix of Earth species and new ones designed for Titan. Artists create sculptures from methane plastic that would be impossible to make on Earth. It's still human civilization, but it's uniquely adapted to its new home. Scenario 2. The Industrial Hub. In this future, by 2250, Titan becomes a giant factory rather than a home for families. Robots and artificial intelligence run huge refineries that turn methane into rocket fuel. Water ice is mined to extract hydrogen for fusion reactors. The entire surface of Titan is covered with automated factories, and the atmosphere is left full of methane because it's useful for industry. Humans don't live on Titan's surface in this scenario. Instead, they live on space stations orbiting around Titan, avoiding the problems of low gravity and cold temperatures. They manage the robots and factories from orbit, but they don't try to make Titan Earth-like. This approach avoids many of the technical challenges of terraforming, but it raises ethical questions. Is it right to turn an entire world into an industrial site without even trying to preserve its natural beauty? Some people argue this is just repeating the mistakes humans made on Earth, where we polluted and destroyed natural areas for short-term profit. The technical challenges include keeping robots working across the vast distance from Earth. If something breaks, it might take years to get replacement parts from Earth, so the artificial intelligence systems must be incredibly smart and independent. Scenario 3. The Hybrid Ecosystem. By 2400, scientists make an incredible discovery. There really is life in Titan's underground ocean. Instead of completely terraforming Titan, humans decide to create a hybrid system that respects both human needs and Titan's natural environment. Bioengineered organisms, specially designed living creatures, slowly convert some of Titan's methane into oxygen, but only in certain areas. This creates pockets of breathable air while leaving most of Titan unchanged. Humans live in floating cities that drift through Titan's thick atmosphere like ships on an aerial ocean. These cities are supported by balloons filled with heated air, and they move around Titan following the seasons and weather patterns. The floating cities grow food using special farms that combine earth plants with organisms native to Titan. It's a delicate balance between human technology and alien nature. Parts of Titan remain completely wild and unchanged, serving as preserves for native life forms. The challenges in this scenario involve maintaining the balance between human and alien ecosystems. One mistake could destroy either the human settlements or the native life. There would be constant debates about how much of Titan should be changed and how much should be left alone. Scientists would need to understand Titan's life forms well enough to avoid accidentally killing them. Picture living in one of these floating cities. Your home drifts slowly across Titan's landscape, sometimes over methane lakes that reflect Saturn's image, sometimes over icy plains covered in orange snow. The city is alive with both earth plants and alien organisms that glow softly in the dim light. It's a compromise between human ambition and respect for other forms of life. Technical breakthroughs needed. Making any of these scenarios real would require advances in technology that we don't have yet. Fusion power is the most important. We need cheap, reliable energy to warm Titan and power all the equipment needed for terraforming. Scientists are working on fusion reactors, but we haven't built one that produces more energy than it uses. We'd also need much better space transportation. Current rockets are expensive and can only carry small loads. To terraform Titan, we'd need to transport millions of tons of equipment and supplies. This might require new types of engines or even space elevators, giant cables stretching from a planet's surface into space. Genetic engineering would be crucial for creating organisms that can survive on Titan and help terraform it. We'd need bacteria that can produce oxygen in Titan's cold environment, plants that can grow in low gravity and strange soil, and possibly even modifications to human genetics to help people stay healthy in alien conditions. Artificial intelligence and robotics would handle most of the actual work of terraforming, since humans couldn't survive the initial conditions. These robots would need to be smart enough to solve problems on their own, since getting help from Earth would take hours due to the communication delay. The timeline challenge. One of the biggest challenges with terraforming Titan is time. Unlike Mars, which might be partially terraformed in a few centuries, Titan would likely take 1,000 years or more to become truly Earth-like. This raises questions about whether humans would stick with such a long-term project. Our longest-running human projects, like some cathedrals or the Great Wall of China, took centuries to complete and required many generations working toward the same goal. Terraforming Titan would require that kind of multi-generational commitment, but on a much larger scale. The people who start terraforming Titan would never see the finished result. Their great-great-grandchildren might not see it either. This means the project would need to be valuable in stages, providing benefits along the way to keep people motivated. Economic realities. The cost of terraforming Titan would be enormous, possibly more than the entire world economy generates in multiple years. This money would need to come from governments, private companies, or some combination of both. The economic benefits would need to justify this massive investment. Titan could eventually pay for itself by providing fuel for space exploration, rare materials that are hard to find on Earth, or simply by becoming a new market for Earth-based companies. But the initial investment would be a huge leap of faith in humanity's future. Some economists suggest that terraforming projects could be funded by selling shares in the New World, similar to how some historical colonies were funded. People or companies could buy rights to land or resources on the terraformed Titan, providing money up front for the terraforming work. Emotional final reflection. A new horizon. Imagine standing in a dome city on Titan, watching Saturn's rings stretch across the orange sky. The air around you is warm and breathable, created by centuries of human effort and ingenuity. You're part of a species that dared to paint on a cosmic canvas, turning a frozen moon into a new home for humanity. But as you look out at the horizon, where methane lakes still shimmer in their natural state, you might wonder, is this really home, or is it just another example of human restlessness? Are we explorers pushing the boundaries of what's possible, or are we running away from problems we should solve on Earth first? Titan isn't just a moon, it's a mirror that reflects our deepest desires and fears about the future. It asks us who we are, what we're willing to risk and what we're willing to change. Mars might be closer, Venus might be Earth's twin, and Europa might have vast oceans, but Titan's strange beauty and abundant resources make it a dark horse in the terraforming race. The universe is vast and full of wonders we haven't even discovered yet. Our time in it is short compared to the age of stars and planets. Terraforming Titan could be our way of saying, we were here and we dreamed bigger than the world that made us. Whether we choose Mars, Titan, or some other world, the important thing is that we keep dreaming, keep questioning, and keep reaching for places beyond our current home. The future of humanity might be written in the methane lakes of Titan, the red soil of Mars, or in places we haven't even imagined yet. What do you think? Could Titan become humanity's next home? Or does the whole idea of terraforming remind us that home is really about the people we're with and the communities we build, no matter how far we travel among the stars? The choice is ours to make, and the clock is ticking. Not because we're running out of time, but because the universe is full of possibilities, and every day we wait is another day we could be reaching for them.